assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. I think correct, no?
Sir, between
So
B
there'll
and
be
C,
a
there is
string.
one more spring, sir.
B and
There's
C.
a string between B and C.
That one. Okay, it is actually. Yeah, I was. There's a problem with the. Okay, no. So he's telling first initially they were placed, then they were suspended. All just after string is cut only we calculated previous problem. Just after string is cut, we are discussing entire our discussion is just after string is cut. Okay, there's a thing, no? So let's write the equation. All three are identical. The springs are identical. Okay, now first, what are the forces? The weight mg. Let's come to the options. So we'll see what will happen to options first. We'll see the later options here. So these are the initial diagram. So they are in equilibrium. So here's some tension T is acting. Let it be here. Now, what is the state of springs? Earlier it was vertical, no? So now we have springs in a plane. It's there in Pathfinder, something very good problem. What is the state of springs? Elongated, compressed.
So natural length.
Oh no, read once question. This assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. So now it is suspended. Got this? So the moment you suspend, what will occur? That also we have to analyze. Then
Sir,
I'm going to cut the string. Yeah.
Sir.
Yeah.
Sir, the spring between B and C will get compressed, right?
Yeah, that's what I'm asking. So it will be compressed. Spring between B and C will be compressed. What about the springs AB and AC?
So they will
Elongated.
They'll be elongated. Okay, now, okay, let's, so here I'll show the spring forces here like this. So this will be the compressed, the compression, let it be Kx2. And this is being elongated. So elongation, I think we show like this, no? And it's a equilateral triangle. So it's telling everything that one. Okay, let's after getting this much of information. What is the thing that one is telling? Connected by three identical springs when placed on a frictionless horizontal floor occupy corners of equilateral triangle as shown in figure. This assembly is suspended. Now, so what I should write the angle between AB, BC. So there's one more troublesome. It should be 60 degrees. The way the question is asked, no, based on that I'm writing it. So you should not blame me. This will be 30 degrees. So why you are drawing like this? Because the question itself, the information given, I assumed that information I'm showing it.
Yeah.
Fine. Yeah.
Sir,
Sir, after it is suspended, the lengths of the sides will change, right?
Yeah.
Yes,
No,
sir.
no. Look at.
Sir, he gave that.
Sir, if they won't change, then how will the tensions, the spring forces balance mg, sir?
Yeah, that's what the question. When you
Sir, the setup was initially kept on a horizontal surface when it assumed an equilateral shape, sir.
now what will happen? Now what happened? We have to assume it to be an equilateral only. That's what the diagram itself he has given.
Sir?
Yeah.
Sir, if we assume it to be equilateral triangle, then how can we tell that they are elongated and compressed when their lengths don't change?
So can't it be possible?
Sir, if all three lengths increase, then the force on one of the masses m2 will be in the horizontal direction.
No, nothing. So here you say it's in equilibrium is telling. So one more thing, try to justify the word equilibrium. Nobody is bothered about the terms. Nobody bothered about the terms. It's in equilibrium. Now I'm going to cut the string. So it should be equilibrium only, and this will be equilateral triangle only. The way the question asked, everything, the conditions given, it should be like this. Okay, now get all the things. So this is compressed. These two springs AB and BC are elongated. BC is compressed. Then only equilibrium is possible. The main purpose is this angle, that one. So you can read the question. Corners of as shown in figure. This assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. What can you predict regarding acceleration of these balls immediately after the thread is cut? So it's telling that arrangement is kept as it is, and he is seeing that the angle will be 60 degree only. That's what he mean to say there. I understood like this. I don't know how you understood, but I understood like this. Okay, now let's assume that, okay, there's a 60 degree. Okay, I'm going to cut it. Before cutting, I think we should get all the forces acting. How to get the forces? So we will balance the weight. Either look at the ball B and C. Kx1 cos 60 degree. This one. So
That's sine 60, sir.
Sine 60, yeah. So this will be root 3 by 2 equal to mg. So keep it value kx1 equal to 2 mg by root 3. Later it may help us. And then what about kx2 along x-axis? Kx1 cos 60 minus kx2 equal to 0. K get cancelled, so this will be x1 by 2, or kx1 directly the value substitute 2 mg by root 3. This will be 1 by 2. So kx2 equal to mg by root 3.
Sir, in the first equation, why did you write equal to 0?
So that is minus some.
Okay, sir.
Okay, these are the initial values. Huh? Okay, now I'm going to cut the string. So let's see what will happen. This was the string. There should not be. Yeah. As usual, weight mg. This is a block. B. This is C. This is A. Yeah. Sudden change in spring force. Anything can happen.
No, sir.
So what shall I do now? The spring forces which were there acting, no? So I should show them as it is. Huh? This was the kx1. Then this particular kx2. I think directly from this only you can tell it, no? Tell me what will happen to block B and C.
Remain at
They'll remain at rest. They'll remain at rest.
Sir, they might move in the
Sir, won't they move downward?
say their accelerations are vanishing small.
Sir,
Huh.
sir, they might move in a horizontal plane, sir, because of a component of force.
Look at clearly. Look at
Sir,
kx1 cos 60 will balance kx2.
sir, but A will be moving downwards, sir. Then kx1 will force will increase, right?
What was our question, Pa? What was our question? Read once.
Yes, sir. Okay, sir.
Immediately after the thread is cut.
Yes,
Yes, sir. They are vanishing.
Just after thread is cut, no?
yes, sir. Okay, sir.
No, always stick on to that word just after, because that is what it is deciding the total course of the problem. Huh? Nothing wrong, because that the word is having a lot of weightage, that we have to be careful. Now BNC will be a test.
Yes, sir.
Now
Sir?
what should happen to
Sir,
Sir, 3G, sir. A will move with 3G.
Yes,
Sir,
sir, 3G.
sir, shouldn't x1 be equal to x2 because it's an equilateral triangle?
what is this new ideas? Why the mathematics you are bringing here?
Sir, you draw all three angles 60, right, sir? So equilateral triangle.
Don't you see this equation? Why you are bringing mathematics here? Don't you see this equation? Whatever you want, you cannot think. There should be some meaningful thinking at least.
Sir, x1 equals to x2, no, sir, because they are of same length.
Oh, I don't know, Pa. Like I can't explain anything further the way you are thinking. Look at this mathematics. Is this wrong? I shaded blue color.
Sir, what wrong did I do, sir?
What wrong? The assumption itself is wrong. The
Sir,
idea
why?
itself is wrong. So you can't just imagine whatever you want and you say that will be correct. So what is the state of this spring? This is compressed. These two are elongated. Look at the forces acting. Look at the system. At least looking at the system, you are not supposed to think here. Or at least after bringing mathematics also, still you are thinking means something, equilateral triangle. So therefore they should be equal. Springs are already equilateral triangle. So is there any rule that like that it was made?
Sir, it's an equilateral triangle. So the length of the spring plus the elongation should be equal, right?
We have one mathematics here. Check it now. Here there are two springs are there. Here only one spring is there. Huh? Okay, fine.
Yes, sir.
So I think just enough information I put on this. That has to be first analyzed properly. Without analyzing, so you can think arbitrarily. Whatever you want, you can think it here. But it should be something related to some problem, no? The thinking. Okay, now BNC will be a test. The conclusion I'm making it now. AB equal to AC equal to 0. Next again, come for these two. Or say like if you are really getting confusion, let's start the problem from here only. So no, so like we could not understand. Leave this. I'm starting the question from here. Okay, fine. Now no problem. Let's assume this is a system. It's in equilibrium. I'm going to cut the string. I'm asking you the acceleration. Fine. If you're really troubled so much, no. So let's start from this diagram one. The diagram itself I'm giving you. Okay, this is a condition. I'll cut the string. I'm asking you now acceleration. Now come for diagram 2. What should be the acceleration of block A now? Acceleration of B and C what will be equal to 0. What about the acceleration of A? Acceleration of A should be equal to mg plus 2kx1 cos 30 by m. G plus this will be 2kx1 value of this will substitute all 2 by m. Kx1 is how much? 2 mg by root 3 cos 30 is root 3 by 2. So this will become g plus 2g 3g. Yes, it's possible. Huh? Vanishingly small. Vanishingly small means almost equal to 0. The interpretation you have to do like this here. Directly, you do one thing. So most of you are unable to understand the situation itself. So let the diagram be this one. I am giving that this is a situation. Okay, now I'm going to cut the string. Tell me what will happen. Fine. Okay, now come for this. There's a one, the best problem what you are having.